Hey, this is Kelly here today, and I'm going to be talking about a very useful C++ function which is called templates. So that you get an idea about why templates are useful, let's go through a motivating example. Take a look at the following code. It's a relatively simple piece of code. Here I have a function print that prints an array, the array being this integer pointer passed in, along with an integer size, and it just loops through the array printing out the items. So, nothing too tricky here. But let's say in my program, I also wanted to print out an array of doubles, and I also wanted to print out an array of strings. Now, as far as we know, the only way to do this is by doing something like this, where I have three separate functions that have the same name but different signatures. In this case, an integer pointer, a string pointer, and a double pointer. This is called overloading a function, when you have a function with the same name but different parameterized types. Now, at this point, you should be thinking, this is computer science, and this is a pretty long and tedious way to create functions. There must be some easier way to do this. And you would be right. We can use something called templates to save us the time of writing out all of these different variations of a simple print function. Templates allow you to have the same piece of code that works with multiple different types of parameters. It's pretty straightforward to use templates, you just have to get used to the change in syntax. If you take a look here, I have an example of that print function now templatized. So every templated function must be prefaced with this template class T. Now whether you use T or some other variable name doesn't matter, because T is really just a variable name for the type that's going to be used in this function. I do have the ability to use more than one type in this function if I wanted to. For example, maybe I wanted to have one class T because I plan on having either an integer or double type, and then I also want to have a class R, which can be any of a user-defined class or something like that. You'll see that next the function signature changed. Instead of having integer or double or string, I now have T as the type of the first parameter. And then the rest of the code is exactly the same. So again, what this is allowing us to do is it's telling the compiler, hey, I don't know exactly what type is going to be passed in for this first parameter. So for right now, I'm just going to call it T. Then when you're using this function within your code, you don't have to do anything special. You can just call it with the different types. So just to show you that this works, I have three different types of array, a string array, an int array, and a double array, and I'm calling print on all three of them. So let's compile template.cpp and run it, and we see that the print function printed for the string array, the int array, and the double array with no problems. Yes, you have a question?
Do we have to list all the types that we're going to use with the template function somewhere?
No, you're not going to have to explicitly list out, for example, with this print function, I'm going to be using types int, string, and double. The compiler will automatically know what types that you need when you call them within your main function. However, one thing that you do have to be careful about is if you use an operator within your templated function, you should make sure that its behavior is defined for whatever types you're going to be using. For example, here I'm using the insertion operator, these two little less than signs. Now, for strings, ints, and doubles, this operator is defined because you can do cout in an integer string or double and it behaves properly. However, if I had a user-defined class, maybe fruit or something like that, that doesn't define how it should behave with this operator, then you're going to get an error if you try to use this function with that specific type. You can also have template classes. And again, here the main difference is just in syntax. So here I have an example of a templated class. Again, we preface the class with template and then name the different types that you're going to be using within your class. So in this case, I'm saying maybe I'm going to be using two different types. So my class is chest. It has an item, which maybe that will be some user-defined class or a string describing what the item is. And then it has another variable weight, which might be of type integer or double depending on how we're weighing the item. Then here I just define a simple constructor. And now take a look at how we create a templatized object in our main method. So when we create the chest object, we have to type chest and then say what types are going to be used within the class. So I'm creating this chest pointer treasure, and then again, when I create the new chest, I have to specify that I'm going to be using the types string and int, and then I'm just passing in some random string and integer value to create this object. And it's that simple. That's how you would create a templatized class. Templates aren't overly complex, but they're a great way to help us reuse our code. This should be enough to get you started, but again, as always, feel free to ask the course staff or look up online if you have any questions. Thank you.